Hello everyone, my name is Arjo Adhikari. I am a senior chemist student at Southeastern Louisiana University. Today I'll give you a short demonstration about gas properties using an online resource called FATE. Just giving you a slight background about this online resource, it provides you a step-by-step instructions for setting up simulation in a computer lab and engaging you with a series of related questions and tasks. The thing that I usually do to get inside their website is just type FATE in the Google search. It's usually the first link that you see. Then I'll narrow it down to the chemistry section and just scroll it until you see a link with gas properties in it and click it. I recently updated my computer with Windows 8, and so that I think I might not have the required Java support or maybe some sort of other software, because this website is not allowing me to run this program online in their website. So what I did was I just downloaded the software. After you download the software, it will give you a program with this screen. At the beginning, I'll give you a slight information about its different features. On your right, you can see an option where you can keep a certain parameter to be constant, whether it might be volume, temperature, or pressure, or even none. And you can also have the option to choose the amount of gas molecules that you want to put inside the container, and also you can choose the gravity acting on those gaseous molecules. And over here it's more advanced tool where you can choose the layer tool, choose the ruler, watch the stopwatch, look for energy histogram, and you can also use the more advanced option where you can choose whether the molecules to collide with each other or to also measure the temperature of new particles. Over here you can see a pump to release molecule inside the container, pressure gauge to measure the pressure, a thermometer to measure the temperature. You can even increase or decrease the volume of the container, and over here it is a device to either heat or cool the system. At initial, you can see the temperature inside the container to be 0 Kelvin and the pressure to be 0 atm. So the first thing that I'm do is add around 100 of those molecules inside the container. I accidentally put around 169 of those molecules. As you can see, as the molecules are inside the container, you can see there has been a rise in the temperature along with a rise in the pressure. So why there is a rise in the pressure? A simple definition of pressure is force acting on surface area. Right now we can consider this to be the surface area, considering it to be a 2D structure. And where does this force coming from? The force comes from the collision of molecules with the container and with themselves. See, the molecules are bouncing off and with the container and with themselves and releasing a force. You can also notice the value of the pressure is not constant. Why is this? It has a simple logic that the collision is not same all the time. Then how do we define pressure inside the container? We just take the average of the pressure and consider it to be the pressure inside the container. Now let me show you a simple experiment representing the gas law. And due to the limitation of time, I'll just show you the Boyle's law. As you know that the Boyle's law states that at constant temperature, pressure of a fixed amount of gas is inversely proportional to the volume of the gas. So by having the temperature as a constant parameter and around 169 molecules inside the container, you can see the pressure is around 0.96 to 0.99 right now. So as I increase the volume, you can see there is a decrease in the pressure, and as I decrease the volume, you can see pressure is increasing slowly, and this verifies the Boyle's law. It is an easy software to play with. If you just play around, it can be very fun. the thing that popped in my mind was, what if I put large amount of molecule inside the container and even heat it at the same time. See, the pressure is increasing, the molecules are bouncing with each other and with the container, causing the pressure to increase, and boom. Isn't it cool? This is a really easy software to play with, and if you want to get more detailed analysis of the gas properties, it can be really helpful. I hope that you guys will give a try.